Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So sit back, grab a notebook, and let's dive into today's problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition, and we're doing problem number 5.6. 1 gram mole of methyl chloride vapor is contained in a vessel at 100 degrees Celsius and 10 atmospheres. Part A, use the ideal gas equation of state to estimate the system volume. So first thing I do is I draw a little picture and say, okay, I've got methyl chloride inside of this box here. It has a certain temperature, a certain pressure, and they gave us the amount of matter that was in there. Okay. They want us to estimate what the volume is. One of the first things I do it right here. Temperature and pressure, convert that into absolute and SI units. Okay, so I've got that in Kelvin. You have to use Kelvin. You cannot use Celsius. You can use Kelvin or Rankine. You have to use an absolute temperature scale, and you also have to use the absolute pressure as well. So if they give you a gauge pressure, you have to convert that into an absolute pressure. I made a mistake on that in the last video, and I put a comment, a pinned comment in there. So just so you guys know, if you didn't do that problem, go back and look at that one and just mentally correct and say, oh, that said gauge pressure, I need to add an extra atmosphere on top of that. So if they give you a gauge pressure, make sure you add an extra atmosphere to that. Okay. In this, they didn't say if it was a gauge pressure, so you assume that it's absolute pressure and kind of go from there. So it gave us 10 atmospheres. There's this many pascals in 1 atmosphere, so then convert that into pascals. Okay. Ideal gas equation of state right there. Rearrange it so that we're solving for volume. And then you plug in all the numbers, and that's what you get for meters cubed, because that's the SI unit. And then you've got your liters there. Okay. Part B, suppose the actual volume of the vessel is 2.8 liters. What percentage error results from assuming ideal gas behavior? Okay, so this is the actual volume that they solved for. Or that they didn't solve for. They somehow measured the actual volume was 2.8 liters, given these other two conditions, temperature and pressure. Okay? Well then, the percent error is equal to the true volume, or the volume that we calculated minus the true volume divided by the true volume. And then you multiply that by 100%, and you get 9.4%. Okay? So that's about how much error we get from using the ideal gas equation of state. It's kind of surprising, actually. Normally, ideal gas equation of state for low temperatures and pressures is pretty good. Well, I guess 10 atmospheres is kind of high, so maybe that's why. I think 10 atmospheres is where you start getting borderline, like not very good measurements. I'd say 10% is kind of far off, but all right. Well, that is it for problem number 5.6. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.